practical, we are making use of a classifier and regressor. How do I make use of if a classifier? How can I make use for regression kind of technique? Okay, so that we are going to see. So let me start my presentation first. Okay, so the topic of discussion today is multi-layer perceptron. Might have heard about this terminology already. In forming any kind of neural network, perceptron forms the core of every kind of network. Okay, so we'll focus on that, how exactly it behaves, how it performs the operation, how it transfers the data, how it will be used to perform the classification in the algorithms here. So it also forms the basis for advanced machine learning. So before actually making use of the image processing or video audio processing, perceptrons are used to perform the common operation that we do in text processing there. So generally, in my practical point of view, I am working as a researcher in mythoscalologies, and we used to work on the data science technologies, max of the projects on, and where we make use of the neural network. We don't go for the deep level, actually deep neural network, which are used to have multiple layers over there. That's possible, but depends upon the application we check it. So rather than creating a deep neural network, we can have a simple neural network of MLP classifier, and with the help of that, solution to many problems can be solved. In previous session also, you might have seen that there are some requirement that we need to satisfy to have a deep learning project, that we require high-end hardwares are present, and your softwares must be capable of handling all. Many libraries like TensorFlow, Keras, or Thenu that are required to work on that. Without that also, your perceptrons are possible. With lightweight hardware or lightweight software, we can create a neural network, and with the help of that, the solution to many problems, many machine learning algorithms we can implement with the help of this particular concept. It is multi-layer perceptron. So let's start with the small topics. I'll focus on different small part in theoretical point of view, and then we'll see from the practical point of view. Okay. So it will be a revision for you. Many things you have already learned about. So let's see how exactly these things are connected, and we'll concern that to the perceptron concept in the neural network. So what exactly neural network is? As we know, so basically neural network is the part of what we call as human inspired computing or nature inspired computing. Generally, I thought of it. Many different computer algorithms that we have seen, or you may have seen, maybe some are in processing phase, in an execution phase. That algorithm that you have seen, that are nature inspired, means the thing is already present in the nature. Natural things, natural algorithms are there. Many behavior of nature, behavior of the animals, birds, flowers, or anything which is living or maybe non-living also. So their behavioral things are interpreted in the form of a computer, and from that computer we devise an algorithm which is exactly the replica of nature or natural things. Okay, so many things are there. Even computer itself is the example of nature inspired computing. When for the first time John von Neumann has devised the architecture of computer system, so he has kept the human body in mind. So human body is having a brain. So he was the first person who has given the brain to computer system, like microprocessor that we call today. And the architecture is created, and many things how actually we communicate, how we take the input, what are the input devices like sensors we have. Based on that, the structure was created. So many such algorithms are present in the computing. Out of it, one of the most astonishing algorithm present in the computer that we have learned already, like neural network. Okay, so what exactly is that? So nature inspired computing, inspired from the human brain. Not only human brain, almost the brain of every animal can also be interpreted in the form of neural network. We are actually thinking from human brain point of view. Human brain is interpreted in the computer algorithms, but there are some neural network present. They are interpreting the or using the brains of different kind of animals also. So based on their abilities, how their brain is containing, if you want to give that ability to computer algorithms, so that brain mapping is in the form of a computer algorithm is also possible. Okay. So human is having ability to identify pattern within accessible information with an astonishingly high degree of accuracy, because our structure is like that. The theory of evolution is telling many things in that, how it is revolved, and many that kind of algorithms are also implemented over here. Now the brain that the human being is having today, it's having some different complex structure. Okay, so how do we learn from that? So whenever you see a car or a bicycle, so you can immediately recognize what they are. This is because we have learned over a period of time how car and bicycles are actually looking like, and what are their distinguishing features are. If you want to distinguish between the car and bicycle, so we know that a car is containing how many wheels are there, what kind of wheels, what structure of it, and how bicycle is looking like. Many things that feature extraction is done by us. Your input device is the eyes, or the eyes, so by which you extract that image, you see that particular picture. Video also like that, it's a video, and based on that you distinguish between car and bicycle. So basically it is just like a classification kind of algorithm of machine learning. We classify what kind of thing, what kind of vehicle is that, whether it's a car or a bicycle, like that. Okay. So in today's scenario, if we consider, so ANN, that is artificial neural network, are the computation system that intend to imitate human learning abilities via the complex architecture that resemble the human nervous system. Human nervous system. So the replica of human nervous system is converted in the form of the algorithmic complex architecture that we call as artificial neural network. Okay, neural network because it's a network of the neurons. Neuron is the basic processing unit that we have in your body. We have having such kind of things like human nervous systems are present. So before actually the neural networks are created, it was studied that how the human neurons, actually human brain works, not neuron. Neuron is the base part of it, just like the token we call in programming language, pixel we call in the screen. Okay, and here we call the neuron, the smallest part, every individual part of your human brain is the neuron. So this is human neuron, which contains some, so this is taken from one of the biology book, and how exactly it works is you just can read in the biology books also. So I'll just explain it. Here we are having the nucleus. So here, this is nucleus, it's a processing unit, and connected to the nucleus, we are having the dendrites. Dendrites are present. Along with that, the axons, exons are also present over there. Dendrites and axons. So dendrites are the lines where actually the input is taken. Okay, from sensory organs. Sensory organs. We are having five senses. Sorry. So that senses are acting like an input device to the human body. Input device to the human body, and with the help of that, it takes the input. Nucleus processes that, and based on that, whatever feature is extracted, nucleus decide that what features you have to extract, and then extracted features are forwarded to the next neuron present in the human brain, and with the help of axon, that is passed to the next neuron there. And again, axon is having the terminal to carry it. Finally the terminals will be connected to the next kind of nucleus, okay, which is a processing unit. So likewise we are having billions of neurons connected there, billions of neurons. Now why I'm explaining that, nucleus is the biological terminology which is used to devise this neural network over here. And this nucleus, if you put in the form of a computer algorithm, we are giving it as a name of perceptron. Okay, so let's see that one. So how human neural nervous system actually works. So billions of such neurons are present in the human body. So these neurons collectively processes input received from the sensory organs. Okay, they process the information which is extracted from that. So data and information, just like we might be knowing the difference between that data. It just everything is coming, and information that we extract from the respective data, which is useful data that we call as information, that is extracted, and that decide what to do in the reaction to the respective input. Okay, that's information, and then we get the knowledge, and from the knowledge we get the wisdom. Like that's actually the process is present, and that process is controlled with the help of this system of the human nervous system. So where billions of neurons are connected together, they are passing the extracting the information, passing information to the next layer, and go on. So finally, how basically that's what we call as experience. See, the base of machine learning, deep learning is a part of machine learning, advanced machine learning we call deep learning. Okay, So what exactly machine learning does? Machine learning is given the experience, observations, previous inputs, and based on that, they identifies what the pattern that they follow. Feature is extracted, pattern followed, machine learning model is created. When the model is formulated, uh, then that will be used to perform the prediction onward. So we are gaining the experience from this respective data. So same thing happens over here also. That neuron is taking the input from multiple sensory organs, processes that, gain the experience. Gain the experience means it is having a model built over there. Now it knows that this particular similarity pattern model is present inside it. Once that identification is done, then we can do the predictions easily. Okay, so this neuron is actually having that one, passing information and gaining the experience. So as you gain more and more experience, you will become more accurate, and that is achieved with the help of the neurons, with the help of the neuron network in the human nervous system. And can it be possible in the neural network also, in artificial neural network also? So information passed to the neuron received by the dendrites as shown in the diagram. Then the nucleus, which is at the center of the processing element, nucleus is responsible for processing this information. Okay, it processes that. It's having many criteria like that. So in algorithm also we apply some criteria to process that information. Okay, the output of neuron is passed to another neuron via the axon. Okay, so terminals are present there, which are just like acting as the output passing terminals or the layers, okay, which is connected to the dendrites of other neurons further down to the network. So if that huge neural network is required, so that kind of things like dendrites and axons and nucleus, how they are connected together, that's required to look for. And this is what we have: billions of neurons connected together by this particular architecture. So when we have to gain the experience, we need to pass the data from multiple neurons there. So you might have learned about one concept called as NLP, not neural natural language processing. It is like neuro language processing, something neuro language something. I don't know the full form of it, but what they actually do, they processes your brain and they train your brain to learn maximum thing with minimum time. That is actually done with the help of computer algorithm in computer system. Everyone is given with the same brain, everyone, so who are using the brain, everyone is given the same brain, but everyone's ability is not same, though the brain architecture is same. Okay, brain architecture is same almost, abilities are completely different. How? Because the training that is done by your neural network in your human brain is different. For everyone is different, that's why everyone's output is different, behavior is different, everyone understanding capabilities, methodology is also different. Remember, this is how the human nervous system actually works. Now let's come with the core part of the talk today. That is perceptron. So perceptron, what is perceptron? So technical name given. So simple perceptron is a simple binary classification algorithm proposed by Cornell University scientist Frank Rosenblatt. Okay, so he has created this particular perceptron concept for first time, just keeping the human brain's neuron in mind. Okay, and perceptron concept is created. What exactly the perceptron is? So it helps to divide a set of input signals into two different parts, yes and no, means like binary classification. First time. Now today it's not only is for binary classification, we are making is for the multi-class classification also, but we have to create a different kind of network to perform the operation of multi-class classification there. So binary classification. Classification means you are identifying what is that. Means this is first category or second category, like binary classification. You might have learned already about it. Okay. But unlike many other classification algorithm, the perceptron was modeled after the essential unit of the human brain, the neuron, which I have explained in the previous slides. It is having many uncanny ability to learn and solve the complex problems. Okay, so study of human brain and human nervous system is involved in design of the perceptron there. Perceptron is electronic representation, or what we call as e-representation of the human neuron, and whatever abilities which are present for human neuron, naturally similar kind of abilities are provided to the perceptron artificially. So to provide that abilities, we need to make use of some mathematical formulas, some mathematical processes, some arithmetic uh, things, algorithms that we need to mention there also, that which are used to train the perceptron to learn the things from there. Okay, so how exactly the perceptron learns? It is devised with the help of the human nervous system, and the neuron form the base for that. Okay, yeah, check it out. So perceptron input and the outputs. So basically, perceptron is, as I told, is a replica of the human nervous system, human neuron present over there, where the multiple inputs are given to it. Okay, so if you consider about the human bodies, we are giving five different kind of inputs. So five different sensory organs are there. That organs are taking the input from different ways. Some take the input from touch, some takes the input from smell, some takes the input from watching, some takes from the voice. Okay, like in that way. And based on that, the neuron processes information and generate the output. For what exactly is that? Like why output is generated? So in general terminology of the machine learning, we call X, we give a name X to the inputs and Y to the output. So in this diagram which is shown over here, like we are having multiple inputs, X1, X2, X3, X4, X5, this we call as the features. Okay, so the data which is given as input, so that features are extracted, then they are given as input to the perceptron, and based on the processing algorithm which is mentioned inside the perceptron will be generating the output. Okay, it gets a binary classification, as I told, whether output or whether that input will go in class number 0 or class number 1, that will be identified here. That's what y output we are having. Few more things are mentioned over here, called as the W1, W2, W3, W4, and W5. So these are the weights. Okay, might be when you are learn about the convolutional neural network, might have learned this thing also, weights. So it's very important to have the weights there. Weight is the adjusting criteria to assign the values or inputs to the perceptron there. We'll look into that, but exactly the weights are used, and what's the application of the weights, means how they are adjusted. Also at the end of this session, I'll show one very funny example how the artificial neural networks are actually formed with the help of perceptron, and how it takes the input in binary format, how it does the classification in binary format, and how it uses the weights accordingly with the help of perceptron, how it takes input and output over there. Okay, so this is what the perceptron's representation is. Here we can have different functions. With the help of that function, the neuron is fired and is expecting the output out of it. That may be either 0 or 1. So if we want more than one output, so such multiple neurons are required to have in parallel over there. Okay, and that is what we call as the multi-layer perceptron. Okay, so let's continue. Perceptron is very simple learning machine. Okay, so learning machine, it takes in few input, each of which has a weight to signify how important it is. Okay, weight, what exactly it was shown in the diagram over here. Weight, the importance, okay, or adjustment of that value in coordination with the perceptron is done with the help of these weights. W1 to W4, which the numbers are mentioned over there, which are used in it. It can take in few inputs, each of which has the weight to signify how important it is, and generate an output decision of 0 or 1. Okay, so 0 and 1 means two possibilities are there. Now if I want to go beyond the multiple possibilities, so I just have to make the combination with 2 raised to n. Okay, so this is 2 raised to 0 actually, 2 raised to 1, not 0, 2 raised to 1, that is 2. So 0 and 1 possibility. If you want to make use of more possibility, 4 possibilities, so you have to make use of one more neuron over there. So 2 raised to 2, 4 possibilities can be identified from that. Then 8, 16, that kind of possibilities are possible, but in that case we have to increase the number of perceptron which are used to generate the output. Okay, however, when combined with many other perceptron, it forms an artificial neural network. In short, we call it as ANN, the first base where deep learning actually starts. That is ANN, artificial neural network, when we combine multiple perceptron together in many format, parallel, sequential. Let's talk about that also, how it is combined with parallel, how it's combined with the sequential things there. A neural network can theoretically answer any question given through training data and the computing power. Uh, Things that we need to know. See, perceptron is used to learn the things. So basically, there is a triangle present which is required to accomplish and to solve the problem which are based on machine learning. Two things I mentioned over here. Third thing is the perceptron. There's the three things which are like I require. First thing is data. Previous data is required. Without that, the learning from that data is not possible. Learning from that is not possible. The data which is given as input, we call this as observations or the experience or the past data, that anything we can call that. That is what we are called as a training data. From that, it will identify the similarities, it will learn the things from it. Second is the computing power. Computing power, and computing power means it's just like a programming language that we use or hardware that we use to perform operations with computing power. Generally, when you're going to have the advanced deep learning, when high end neural networks are created, so it's required to have a graphics card in your system also, because parallelly it can execute multiple tasks, and the performance of system can be improved. Whatever you're getting in 10 minutes, I can give generating 1 minute also. That's it. Computing power, software and hardware, and programming language, software and programming language that is required. And third thing is the statistical method to identify the pattern inside the training data. Three things, that is training data, statistical methods, and the computing power. Statistical method is present in perceptron, where we are having a concept called as activation function. We'll go in detail about activation function further, which is used there. Uh, that will be used to find the similarities in the data, training data, and then with the help of computing power, we build the artificial neural network. Then we decide how many number of neurons should be present in the network. It's a dynamic. It's not like that I need you created the network and it's always contain 10 number of layers or 10 number of neurons in single layer. Okay, it's not like that. It can contain any such number of layers that we will decide. It's a dynamic network, and as you grow, you're growing the network, abilities may change. Abilities may change. It's not always changing. Like, it's not always that I'm creating lakhs of neurons and I'll have highest accuracy there. Okay, abilities are somewhat limited sometimes. This is my experience actually when you're going to train the artificial neural network. So maybe because of the variations in the data, because of the data is not so much perfect, or because of the less number of layers or the number of hidden layers you're using there, your performance may not be up to the mark. Okay, that may be the problem created or present over there. Okay, now multi-layer perceptron, those MLP in short, it's a perceptron that teams up with additional perceptron stacked in several layers to solve the complex problems. Okay, definition of the book like that. So in general, we combine all of these perceptron together in the form of the layers. Okay, first layer, second layer, third layer. When I started my presentation, on the first slide, I have given one diagram. Okay, this is what we call artificial neural network. It's present there, but it was not multi-layer. Okay, so multiple layers are possible. So we can team up them with additional n number of perceptron there stacked in several layers to solve the complex problems. So when you add multiple thinking units inside it, just consider perceptron is a thinking unit. It identifies the similarities in it, identifies find the model in the given data. That's what you call a thinking unit. And when you are layering up more than one thinking unit, so obviously ability to solve the problem with the help of that is will be more. Okay, so each perceptron in the first layer on the left, okay, just I'll show that diagram. Okay, let's have it. See this. This is your multi-layer perceptron. Simple example are given, not compulsory that only 3 layers, 4 layers, 5 layers are present over here. This is used for the binary classification. Okay, binary means either having first output or the second output. So which output we desire, first or second class, first class or second class. So that case, this kind of network is possible. So every individual circle shown over here is a single perceptron. Okay, input layers. So in input layer, we are having 2 perceptrons present here. This is a hidden layer. and this is the output layer. So basically, input layer and output layers are actually interacted with the user who is creating this network. We provide your input through the input layers. Okay, and every perceptron in that input layer is connected with every other perceptron in the next layer, hidden layer we call. Why it is hidden? Because user is not directly interacting with this particular layer, so it's hidden from the user. Input layer we are giving input, output layer we are generating the output where user interaction is there. So output layer is single, so either 0 or 1 can be outputted. It means that we can have a binary classification present over here. Fine. Okay. So that's it. Each perceptron in the first layer on the left, that is we call it input layer. Okay. So everywhere in almost every session may you may have seen this diagram of the neural network. Maybe layers are different. So your RNN is something different, which is feeding the input back to the output back to the input. So some different kind of dynamic networks present. And if you consider about convolutional network, it's containing again convolutional layers are present there. Layer may be more, one, two, or more than that are possible. In general, ANN should have at least one single hidden layer, which is not directly having the interaction or communication with the user of the system there. Okay, so input layer send the output to all of the perceptron in the second layer. Okay, the hidden layer that we call, and all the perceptron in the second layer, that is hidden layer, send the output to the final layer on the right, that is what we call the output layer generally, simply. So they are how they are connected together in general, in theory, in graphical format. You just can observe that how it is the multi-layer perceptrons are created, input and the output. If some data sets are given to you, consider any data set. So I'll be showing any common data set. They consider data set about the iris, you might have heard about. Iris is a multi-class classification data set. Actually, three classes are there which are generated from that. So when three classes expected, so this should have a combinations of two present over here. And input layer, input things are four. Four features are present in the iris data set. So in from the input, it might have ability to fetch at least four different inputs as to the respective artificial neural network here. Okay, so multi-layer perceptron MLP is called as artificial neural network. Okay, it's a network of it. Perceptron network is created, and artificially that neurons are connected, just forming simple plain replica of the human brain. That's what it's called as artificial neural network. Artificial intelligence. Now today's algorithm that if you see, artificial intelligence algorithms are almost they are based on this particular concept there. See, may have maybe this particular terminology or the confusion is created in your mind that what is the meaning of deep learning? How can I differentiate deep learning, artificial intelligence, and the machine learning? So many terminologies are there which are differentiating them, and many terminologies are there which are common in all. Out of it, neural network is common in all. So commonly neural network we can use in plain machine learning also. Even we can make use of in deep learning also and artificial intelligence also. It contains that ability so to be the part of something which is uh, learning from the given data, and based on that it performs some predictive analytics based on that. Even not predictive analytics, multi-layer perceptron is used for descriptive analytics also, but in rare cases it is used by the data scientist. It means that we are using it for unsupervised learning. Unsupervised learning. So generally we use for supervised learning max number of times when there are you need to create a model of it, and then you have to do the predictions based on that. Okay. So multi-layer perceptron. Each layer can have a large number of perceptron as it was shown in the diagram, and there can be multiple layers. Okay. So the multi-layer perceptron can quickly become very complex system. I'll show some complex systems there. Uh, some 3D animations are also present. I'll show that one. You can go to the TensorFlow also in some of the upcoming sessions. I'll show how exactly TensorFlow works. So TensorFlow is the library which is used to create the neural network. It's created by Google actually. And neural network, even multi-layer perceptron is also possible to create by using TensorFlow. In general, scikit-learn also, if you're knowing scikit-learn library in Python, that is also used to create the multi-layer perceptron. In general, it is used because performance is good as compared to other. It does not require any extra special hardware also. Okay, so there can be multiple layers. So multi-layer perceptron can quickly become a very complex systems. Huge number of things can be connected over there. Okay, if you consider, if you know the concept of decision tree, you might have heard about decision tree or random forest. Random forest is the extension of decision tree algorithm. That is also one of the complex architecture present and available there. But decision tree or the random forest architecture, they are not so dynamic. Decision tree is not actually dynamic. You give a data and based on that a tree will be created. Okay, you can't extend that tree. It's I don't want 10 level, I want 15 level of trees. It's not possible based on the data the trees are created there. uh, okay, so just connected to that, if you consider about the architecture of the neural network, it is dynamic. You decide how many number of layers you require inside it, multi layers, how many number of epochs you require. We'll talk about that. May have You may have seen that in convolutional network or RNN also epochs are given. In multi-layer perceptron also epochs are required. How many number of times you need to perform the operations. Okay, let's talk about that also. I'll show that one after this. Okay, so multi-layer perceptron has another name that we called as the neural network. In many different libraries that you have to implement. For example, if you want to solve or a particular problem, or you have to build the model of the learning, deep learning or machine learning, so we require different kind of classes which they are present available there. So some are using the name neural network, some are using the name perceptron, a multi-layer perceptron like that. So they are almost similar. A three-layer MLP, just like diagram I'll show you, it's called as non-deep or the shallow neural network. Okay, and an MLP with four or more layers is called as a deep neural network. Let's see this. Okay, just a minute. Okay, let's talk about that, how exactly it is shown. So this is diagram. This diagram is shown. It's called as shallow neural network. Okay, non-deep, not exactly so much layers are present over there. The deep means any number of lot many 10, 20, 100,000, 10,000 deep. That's why the name deep is given there. Okay, four or more layers called a deep neural network. Now, one difference that between the MLP and the neural network is that the classic perceptron, basic perceptron that we use, it's having a decision function. Means the data and the weight which are taken as input, what operation to do onto it, that is decided by the decision function. We call it the activation function also. It's a step function, and the output is binary. Output is always binary in that case. So that's what common thing that we can identify MLP and a neural network. So we can have MLP to have multi-class classification also. In neural network, everything is possible. Just like even binary classification, multi-class classification. Now today we use generally for image classification, we use for audio classification, audio identification also. Even we can use for prediction of the next data also. Just like I want to predict, you're typing something in the Gmail, like you might have seen that hello friends, and you can find and automatically attachment name will come there. That is also done with the neural network. The decision function different over there, and they are using the recurrent neural network RNN to perform that operation. So, but in this case, MLP and neural network, they are differentiated with this decision function. Activation function is a step function, and output is binary in case of MLP. In neural network that involved from MLPs, other activation function can be used which result in output of real values. Okay. Not only step function, but different kind of the functions are used in MLP, which will result in different kind of values, not only the values of zeros and ones, but can have a values between 0 and 1, between 0 and 1, or between -1 and 1. See, some kind of MLPs. So MLP is again modified with the problem to solve, which are of regressor categories. Okay, classification and regression. These two tasks are there, which we accomplish with the help of the supervised kind of learning there. So classification is actually most of the algorithm which are present in the machine learning and deep learning that used to solve the problem of classification. But maybe you have seen different algorithms or the case studies which are based on the classification system. MLP contains the ability to have the regressors output. Means when we are going to generate the output, which is in the continuous format. Okay, so any possibilities between a specific range or not within the range also. So if you want to generate such kind of things, so NLP regressor ability is also given. I'll show that how exactly the classes are present and how we can use it for performing the regressor abilities out of it. Okay, so this allows probability-based predictions or classification of item into multiple labels. Now, the multi-layer perceptron is the algorithm which is coming under the probability-based predictions. Probabilities are present. What is the probability that the class is zero? What is the probability that the class is one? You may have learned about some probability-based algorithms, like we are having logistic regression algorithm. Logistic regression is a probability based algorithm, or the new Bayes classifier, Bayesian classification algorithm, which is also one of the algorithm which is probability based. Okay, so multi-layer perceptron algorithm is also probability based classification of inputs into multiple labels. When you have the multiple labels, so what is the probability that this data will go into first class or the second class? So wherever the high probabilities are present, based on that the classification is done. Even by using programming, we can identify the probabilities of the given input for the respective class also. Okay, yeah, so let's talk about the structure of the perceptron. Single perceptron, multi-layer perceptron, they are almost same here, but multi-layer we are having such kind of things multiply connected there. See, so four things which are mentioned in the structure of the perceptron here. So first layer which we have uh, talked about is the input layer. Input values are present. The second layer, but not exactly it's a layer, these are the weights. Okay, weights and the biases which are present for every input which we are giving to the activation function here. Okay, and then the third is weighted sum, where we actually perform the summation of all the weights, and the last one is the activation function. So by default, as I told, for MLP we have having a step function. Okay, diagram is showing that one step function there, which is the activation function. Let's see one by one. If you start from the input values here, the first layer, that is what we call as the input layer, where some n number of inputs are present, starting from x1 till xn, or we starting from x0, we'll start from n till x of n minus 1. Okay. The perceptron takes real values as input. For example, if perceptron is tasked with classifying the iris flower, okay, commonly iris flower, which is present in the as a data set in many packages. In deep learning also, it's one of the data set present there. Two inputs could be the length and width of the flower petals. Okay, petal, what we call sepal width, petal length, and petal width. These are the four inputs given to the which are present inside the iris data set. Okay, iris flower data set. That four inputs, so four different neurons will be there in the input layers, which will take the inputs. Everyone will have a single feature to take, like x1, then x2, x3, x4 features will take that. So here it's mentioned two, four are possible there. So four neurons will take the inputs from the iris data set. Okay, so next to that we are having weights and biases. The weights represent the relative importance of each of the weights to the classification decision. Okay, and bias weight is added and multiplied by a constant equal to 1. So basically, most of the time when the data which we are going to make use of it is not connected, not concerned with the particular operation, so we'll be making use of the weights over there. Okay, so maybe in case of MLP, these weights are binary. Either we can have a 0 or 1, and then we are performing addition of them and generate the results there. Practically, I'll show one operation how exactly these weights plays one of the role. How can I make it 0 or how can I make it 1, and then perform the operation of addition of all of them together with the help of the function of weighted sum. So the input values are multiplied with the weights and summed up. Okay, so whatever weights are given there, W0 to Wn, they are multiplied with the input values, and finally the summation of them is done. So just can check the symbol which is present over here. It is the symbol of summation. So summation, all of these are done together at a common point, so create one aggregate value. Okay, it will create one aggregate value which is fed into the activation function. combine all of them together. This is for single perceptron only. Okay, so this is called as weighted sum when the weights are multiplied and addition is done there. And then finally, whatever the weighted sum is generated, that will be fed to the activation function. And finally, if you go to the activation function, it's a function that generates a classification decision. For example, in case of iris flower, so two things are mentioned over here. I just again, setosa and versicolor. Actually, three classes are present over there. Okay, and that three classes are, as we know, it is setosa, versicolor, and the virginicum. Okay, so basically, if you consider about the binary classification, if single thing is present, so either we can generate 0 or you can generate 1. So that is just like a binary classification created. Yes, this is simple structure of perceptron is present. How exactly the data are taken, weights are added, weighted sum is done, and finally, we will be having an activation function. Okay, uh, we'll have a simple example also about that, how to solve the respective problem with the help of the neural network in real, because see, multi-layer perceptron having n number of such inputs present there, and if you want to create practically, so your data set should be that much perfect. But in common sense also, if you want to solve a specific problem, that also we can solve. Like, for example, I want to differentiate between the cat and dog. Okay, so I'll extract the features first. What are the features that dog carries? What are the features that the cat carries? Like, they're having similar features also. They both are having tail, both are having nose, both are having four legs. But what is their sound? Okay, so and many more, whether dogs are like, all that things are extracted and then will be given as input to the features, and then classification is possible there. Now, how exactly the perceptron learns? What's the process? So four different stages are there by which the learning of the perceptron is done. It was shown in the diagram also, but we'll go in detail about the step by step how exactly it learns that, and then how it will be converted in the form of algorithm there. Okay, so first step, it takes the input, multiplies them with the weights and compute their sum. So inputs layers are taken, then we are having the weights present, then find their addition of all. Then adds the bias factor. The number one is multiplied by the weight. That's the second step which is performing learning process. The third is feeds the sum through the activation function. Okay, activation function. So many activation functions are the, in general MLP, the default function, as I told, it is a step function. Okay, so some is fed through the activation function, and the final, the result will be the perceptron's output. So whatever we got the result, that will be the perceptron's outputs. Four steps are there, which are done with the help of the perceptron. Now, every step is given with a different names. Okay, different names are present in that. Let's go step by step how the learning mechanism of the perceptron is actually taken place. So take the inputs, multiplies them with their weights and compute their sum, as just shown as the first step in the perceptron learning. Okay. Why actually this step is taken? And that step I've given the name as the back propagation. Now, many things are in back propagation, not a single line. We'll talk in detail about the back propagation here. So, why it's important? The weights allow perceptron to evaluate relative importance of each of the output. Okay. Evaluate the relative importance of each of the output. I just made it in different color here. Importance. How, see, we just talk about something like in statistics. Basically, what happens? I just explain with some example. Uh, Basically, statistical models or machine learning models are based on the relations. Okay, they are based on relations. Relations are important. How your input and output are related together, or first input and output, or second input and output, or third input and output, how they are related. Based on that, the model is becoming more and more accurate. Fine. Now, some models are there. Some models like consider nearest neighbor model, or consider like support vectors model. So these models are created like that. They are using such a mechanism by which magnitude of the data affect the output. Magnitude of the data affect the output. Means, for example, two features are given, x and y. X range is starting from 0 to 10, and y range starting from 1 lakh to 2 lakh, something like that. So y's magnitude is high. That's why impact or importance basically of y input will be high, or highest 99% will be there in the output. It means that x is of no use. X will be of no use. That's what the meaning of it is there. So this algorithm will have impact in the output when the magnitude of the data is high in that case. So what we actually do in that case in core and basic machine learning, we generally normalize the data. Means we can apply feature scaling method there, by with the deviation of all the data, x and y will become same. Okay. And we can apply the min max scaling where the ranges of both will be same. So either we can uh, keep in the same range, or we can increase the values by using some multiplication factor, or you can decrease the values by some, using some multiplication factor, so that the ranges will be same. Okay, that many things are involved in that. But in case of the mlp, so evaluation is done with the help of the weight. So weight are used to allow perceptron to evaluate the relative importance of each of the output. So as per the values which are given to the respective input, their importance are adjusted with the help of the weights. Now why? Because every feature should be given the similar, almost similar kind of importance there, so that maximum learning from the given feature, input feature, is possible. Okay, that's why weights are required there. Neural network algorithm learn by discovering the better and better weights that result in more accurate precisions. Better I use double times, especially better and better weights. If its adjustment is not accurate, obviously your algorithm's accuracy will decrease. Okay, weight adjustment should be like that. Importance of every feature should be pursued equally. That's why this weight adjustment plays very important role to have the accurate prediction generated out of it. Okay, there are several algorithms which are used to fine tune the weights. Fine tune, find you might have learned about this name. Fine tuning is almost making the perfect thing. So perfect things which are made by with the help of the back propagation algorithm. So back propagation is one of the algorithm which is used to fine tune the weights, adjust the weights. Means if weight is not appropriate or the proper one, so reassign, readjust it. That is called as the back propagation. So fine tune of that weights is done with the help of a step called as the back propagation. We'll go in detail about back propagation. So remember the task about the back propagation right now, and let's continue with the second step, that is bias. Adds the bias factors. The number one is multiplied by the weights. This is a technical step that makes it possible to move the activation function curve up and down, or left or right on the number graph. It makes it possible to find in the numeric value of the perceptron. Numerical values of the perceptron. Remember, one thing, uh, let clear why exactly the bias plays very important role here in the neural network again. Let's take an example. Like, for example, if I have written in the programming language that if 19 is equal to 20, so 19 is equal to 20, this statement is false, 100% false. False means there is no any fuzzy logic also present inside it. 100% false. 19 equal to 20. But from the machine learning point of view, okay, from the machine learning point of view, if you consider about that, this statement is true, but it has 95% accuracy. It is having 95% accuracy present there. Now if you make this value more near to the 20, like 19.5 equal to 20, again in general it is false, but according to the machine learning criteria it is true, but accuracy is 98.5%, something like that. Will be increasing the accuracy. If it is 18, it is 90% true. Okay, out of 20 is equal to 80, 90% true, like that. So if you adjust it accordingly, if you go with the values plus or minus, so your accuracy will change. The prime focus of the algorithm which learns from the data, they are focusing on the accuracy, how we are making the data, how we are making fine tuning it so that more and more nearest results can be achieved. Okay, this is what is possible with the help of the biases here in the neural network. So this adjustment is done. You're fine tuning numerical values, numeric outputs of the respective perceptron. The third, which is connected to, it's called as the activation function. What it does, it feeds the sum through the activation function. Whatever sum calculated, it's fed through the activation function. The activation function map the input values to the required output values. Okay, input values to the required output values. That is done with the help of activation function. So that function, there are some formulas present inside it. With the help of that formulas, the outputs are generated. Okay, just like that. Just take an example how exactly it perform the operations over there. Some activation function identify the maximum of the inputs. Whatever inputs are given to activation function, identify the max and generate the result. Some perform the average, maybe. So average will be the regressus output actually. Some performs if the value is above this range, then it is 1. If it is below this range, it is 0. Like I want to generate the output is temperature is high or low, and I'm getting the input weighted sum is like 35. Okay, so there's a threshold criteria mentioned over there. Above that, like above 30 value is high. So 35 the temperature generated, but it is generating binary value in high level. And if I generating the result in 28 degrees, okay, in case of 28 degrees, that is low, and your output will be 0 in that particular case. Like that, we'll be having activation function generated. It can be anything. At the end of this particular presentation, I'll be showing different activation functions and what formulas that they are using. Even in practical also, I'll show you how to make use of the activation function to perform the respective operations here. So for example, the input values could be between 1 and 100, and output can be between 0 or 1, can be 0 or 1. The activation function also helps perceptron to learn when it is the part of multi-layer perceptron. Certain properties of activation function, especially its non-linear nature, make it possible to train complex neural networks. So basically, there are three actually kind of different activation functions present, by which linearity or linear functions are, some are linear functions, some are non-linear functions present. Just like one function is the sigmoid function is present. Like if you have heard about the logistic regression, how logistic regression solve the classification problem with the help of the sigmoid function. So same function is used here also to identify or to find the classes of the given data. Okay, so that every activation function contains some properties, and based on that properties, whether they are linear or non-linear, they are training the perceptron to create more complex neural network. Maybe if again the speed of that activation function is different. If it is slow, so neural network will be slow. If it is faster, neural network will become faster. So because whatever number of perceptron are, that number of activation functions are also created, and obviously the performance will also get affected with the help of the complexity and performance of the activation function here. The fourth one is the output. The perceptron output is the classification decision. So what exactly we have generated the output from? Binary classification, two outputs, multi-class, multiple. So in multi-layer perceptron, the output of one layer's perceptron is the input to the next layer. As again, revise the diagram. Okay, the output of the final perceptron is called as the output layer, and it's a final prediction of the perceptron learning model. So as we have seen in the diagram also, this is not the part of the hidden layers. The layer which are accessible to the user or the programmer, we are using this particular thing, output layer. Okay, so final layer of the whole multi-layer perceptron, which is having ability to generate the final output that will be given in any particular format. In previous examples also, you might have seen in CNN or RNN, where the output layers are there, when output layers are actually doing the predictions, where how exactly in what format they are doing, depending upon the structure, architecture, or the layers that you have formed, that you are embedded inside the network, your output will be different. So output can be of any format. In general, MLP generate the result or the output in the binary, means it's in either 0 or 1. So if you want to go beyond, so n number of such uh, fired neurons should be present in the output layer. Fourth stage. Yeah. Let's come in detail about the few more topics like back propagation, how exactly it's required, hyperparameters, and the some more advanced structures are present. Okay, so from classic perceptron to full-fledged deep neural network. So this is what we connected with the transformation, a new topic which is connected with the ANN here. Classic perceptron, common perceptron, if you want to convert that into a fully fledged deep neural network. So few things are expected. Although MLP and neural network are essentially the same thing, you need to add few ingredients before an MLP becomes the full neural network. Ingredient. So maybe see in general deep learning in when you're using that advanced neural network, so basically pre-processing is done by the neural network itself because they are containing that abilities. We are adding that layers over there. We are adding that ability to learn from that. Okay, but in general when these ingredients are added, that ingredients will convert your MLP into fully connected neural network. And what are that? So they are just mentioned words like back propagation. We have already seen a small simple summary of the back propagation. We'll go in detail about that, how exactly these are done, what are the techniques involved in that, why to do that, and how it is affecting the performance. That also we'll see. Hyperparameters, hyperparameter and hyperparameter tuning are there. In practically, when you are going to create the network, that time also these hyperparameters are present. What are the techniques used by the neural network to find the hyperparameters? Means is most important and useful parameters there. That also is one of the important part. And the advanced structures. Advanced structures means few more things are there, like number of repetitions, max iterations, or batch sizes. Like these are the advanced structure which are involved in that. Let's go one by one, from back propagation to hyperparameter and method to tune the hyperparameter which are used by the multi-layer perceptron and advanced structures. Now, back propagation. We have seen this already. The method why we do back propagation for adjustment and by making a fine tuning. That is what to know. And remember here, just what fine tuning of the weights is done with the help of the back propagation technique. So back propagation algorithm allows you to perform a backward pass, which helps to tune the weights of the input. Fine tune the weights of the input. So initially, when the weights are given, they're randomly assigned. Okay, but I have to make use of a neural network actually makes use of the back propagation method. With the help of that, the fine tuning of the weight is done. Fine tuning of the weights which are given as input to the things are done. Like for example, just consider it like the example which I mentioned, 19 and 20. If 19 is equal to 20, like output is generated is 19 and affected expected is 20. So you have a difference of 1 there because the weight multiplied is generating the result 19. Okay, so what we'll do, we'll go to back propagation stage again, go to the previous neuron. Okay, backward pass we call it as, and adjust the weight accordingly. So your value will become more accurate than the previous. Previously it was 19. Now after adjusting the weight, it will become 19.5. Now it is coming more closer to the expected value 20. Okay, again I'll pass this value backward pass again to find a difference between both. I'll make it 19.8 and 20 will be there. Now onwards weight adjustment is not possible. So maximum value is 19.8, expected is 20, and neural network will generate that. But what advantage it carries? It will be having the highest accurate value generated from that perceptron particularly. Okay, that's what we actually do in back propagation. A backward pass is done. Back propagation performs iterative backward passes which attempt to minimize the loss. Okay, the prime task of the back propagation to minimize the loss or the difference between the known correct prediction and the actual malprediction, just like 1920, as I told, difference between the known correct prediction. Okay, what was the correct prediction present there and what is the actual prediction? So we are having a difference in that error loss. Okay, and we have to minimize it. So to minimize that, you must have to do the adjustment to the weight function, which is multiplied. So what we'll do, we'll pass that value again to the previous neuron. Backward pass is done there. the weights are adjusted. Okay, so with this backward pass, the weight move towards an optimum that minimizes the loss function and results in the most accurate prediction. Fine. And even again, you might have seen that in convolutional network, there are some loss functions are mentioned. Okay, binary cross entropy is used there very commonly. I also use the same. Okay, RNN I think may not require loss function, but CNN requires that loss function. So that loss function is actually identifies, which is used to minimize the loss between the stages when you're passing the data from one neuron to the another neuron, so that more accurate prediction results are identified from there. Okay, so it's an algorithm commonly used to train the neural network because that only more predictive analytics are possible. So when neural network is initialized, weights are set to the individual elements called as neurons. So every individual neuron will be set with the respective weights there. Then inputs are loaded. They are passed through the network of neurons, and network provides an output for each one given the initial weights. Okay. Backpropagation helps to adjust the weights of the neuron so that the results come closer and closer to the known true result. Okay, that is main task is there, which we have again summarized in the fine tuning format, making the results more and more closer towards it. Okay, see one thing I observe multiple times, like when I'm solving a particular problem with the help of any particular algorithm, like I'm using random forest, I'm getting 98% accuracy. Okay, any problem I solved recently 98%, or support vector machine linear kernel is giving 96%, something like that. Another data set again decision tree is giving 97%, 96%, or 90%, like that. When we apply the MLP classifier, and I actually make use of the hyperparameter tuning, where we can specify many things inside it. Okay, I'm getting the accuracy almost not almost equal to 100%. So that is achievable from the uh, MLP classifiers max number of time, because the thing which is affecting the accuracy of it, fine tuning is done with the help of the back propagation. So when you actually identifies how is the back propagation, how the repetitive back propagation and forward pass are done, it is trying to increase the accuracy at some extent level. Okay, check this out. So this is how the operations are done. We are having inputs, okay, I1 and I2, and then to the next neuron we pass this information by adjusting by using the weights. Okay, here will be passed to this particular neuron. Fine, and I'll generate the output. Okay, so what is the expected outputs are there, as we are given input and output both for training the machine learning model. So expected output difference and the generated output from these neurons, their difference is called as a loss. So if the loss is high, so to adjust it, we'll send this value back to the previous neuron again. Okay, accordingly that the weight, okay, like input one is containing w1 as the weight, that will be adjusted. And once the weight adjustment is done, again I1 will use a newly generated weight. Okay, and newly generated weight will be given here into, okay, will be used, and then a new value will be generated. Again we are going to see what is actually happening. Okay, so whether it's having any effect in the loss minimization. Once the loss is minimized, okay, once the loss is minimized, again go ahead. So this value we can set manually by hyperparameters. Okay, you mentioned how many number of time you require, that generally we call as epochs, maximum iteration basically, by which how many number of time you have to perform the forward pass and backward pass, back propagation, that's also mentioned. And based on that the more and more accurate result can be identified. But the problem is that we actually waste the time in this particular process. Okay, so generally a deep learning algorithm takes too much time to train because of this complexity and the processes involved in that. Okay, you may have learned in the previous sessions also. uh, the deep learning algorithm takes some days also to train, though you are having high end computers present in that, and good softwares are there. Parallel computing, distributed computing, then also it takes days to train it. Okay, but the thing is that these things are involved, that's why they are taking too much time. And the model which is generated out of it will be the most accurate models present there. Many things, like we'll take an example. You might be knowing the Facebook uses one algorithm called as fast rcnn. Fast rcnn, this is different algorithm actually. and they are devised by the Facebook itself, fast RCNN, by which the image segmentation and the prediction is tagging is done with the help of that algorithm. So much fastly they perform the operation. They are devised by themselves, and many different derivatives of that algorithms are available. Even there's available in open source also. So there in the that algorithm, they are basically making use of this back propagation process more accurately. That's why it's possible to have good predictions out of that. Like for example, if you upload some image on the Facebook, image means photo on Facebook. So there are four persons present in that. Facebook identify this person is present in the picture. So do you want to tag him? Okay, that is what question Facebook is asking. Okay, you might have observed that. That's what is why it's so much accurate, and most of the time these things are accurate. Even one more thing, I don't know whether they are using that or not. Google is created the algorithm, this algorithm in TensorFlow, and Google Photos also contains it, similar kind of algorithms. By with the tagging system, such tagging algorithm is created, and based on that they are also making this more and more accurate by this particular step. Okay, even they are taking input from the user also. Okay, this images, these two persons are same or not, like that it's done there. Okay, that's it. Okay, so this is the first part that is required to remember here in the back propagation, which plays very important role to create more and more accurate model of multi-layer perceptrons. Now, second part is hyperparameters. It's actually in it's very detailed concept is there. Hyperparameter. It's a part of machine learning also, and we generally call it as hyperparameter tuning step, by which more accurate features are extracted, and that will be given to train the machine learning algorithm there. Okay. So in model neural network, the aspect of multi-layer architecture structure, such as the number of layers, how many layers you want, or initial what should be the initial weights of your neurons, or the type of activation function, which activation function you have to use, and the details of learning process are treated as parameters and tuned to improve the performance of the neural network. So this is called a hyperparameters. Means you create a network. It's not like that given the input and created the network. Okay. Network is created, it's dynamic, means as per our ideas, means as per our requirement, the network will be created. Okay. As per our requirements. So as per your requirement, you need to specify. So generally, input and output layers are automatically identified, because once the data set is given, okay, so once the data set is given, so based on that, input output layer can be easily found. But what internally it should contain, how many hidden layers you want, what should be the initial weights present, they're randomly given, but even we can also specify that. Or activation function also, we can specify what activation function you have to make use of, so that a perfect classifier, perfect MLP classifier can be created there. So all that things are we call as the hyperparameters, which plays very important role to build a robust machine learning model of the neural network here. So this is called a hyperparameter tuning. The tuning hyperparameter is an art and can give huge impact on the performance of the neural network. So it's a supportive process which is required to create more accurate, healthy, and robust architecture of the neural network there. If you have learned about the machine learning, so this is also one of the most important part that is done over there, because choosing the important parameters, okay, will give highest accuracy most of the time. For example, if I'm having 40 features or 50 features present in the data set, and when I give all the features, your deep learning is taking days to learn, and 40 50 features are given, so it will take weeks to learn, like that. The part is that out of all the features, which are the important features, they are having actually having the importance impact on the final output, that is required to be known in prior. And hyperparameter tuning is done as a supportive step in the artificial neural network here. So general parameters and the hyperparameters we call as model and the hyperparameters here. So model parameters are the internal to the neural network. They are internal, means you are not going to change them directly. For example, neuron weights, remember, they are estimated or learn automatically from the training samples. These parameters are also used to make predictions in the production model. Okay. as per the inputs given. So if input is in specific range, or if input is of specific type, okay, or specific magnitude that they carries over, based on that, the neuron weights are estimated, and they are taken from the training sample that we use to train the algorithm there. Then hyperparameters are the external parameters set by the operator of neural networks. We set it. Developer, operator, developer. Okay. Just like selecting activation function to choose, or the batch size used for the training that you have to choose. External parameters. So model parameters which are decided by the algorithm. Okay. So which are ideal for that. Ideal parameter the algorithm decides based on the inputs, or based on many factors which are pre-processed by the algorithm there. Okay. And second is hyperparameter that we choose, and which are used for the training further. So hyperparameters have a huge impact on the accuracy of the neural network, because if I'm using a step function like sigmoid, and if I'm using a step function like ReLU, so maybe sigmoid is giving 98% accuracy, ReLU is giving 91% accuracy, so you're having a difference of 8%, 7% there, maybe. Or maybe the number of iteration you provide, number of iteration you are given 10 only, and after that I'm giving a number of iteration 20, so 10 and 20 is also in 5% different, maybe having that. So there may be different optimal values for different values, and non-trivial to discover those values, so that specific technical methods are statistical methods are present. With the help of that also we can identify the tuned parameters tuned parameters for the neural network here in case of MLP. So the basic hyperparameter that we use for the neural network, maybe again in the previous session you might have seen about the networks are created as a case study. These values are given there. Number of hidden layers you can specify. How many layers you want specifically, number of layers and number of neurons per layer that you can specify. Or dropout rate, that also we can specify for hyperparameter of neural network. Or the neural network activation function, or the weights initialization, how the weight should be initialized, what's criteria to apply, or we specified manually or not. Like, so these are the common hyperparameters used for the artificial neural network. See, so how they are affecting, what's the meaning of them? I'll show you one actual example of scikit-learn's classifier, which is for neural network here. In that, almost 30, 30, 20, 30 parameters are there. Many of it, even I also have not used many parameters, but out of all, few 4 5 parameters are very important role, important, and they plays very crucially important role to decide the accuracy of algorithm, even the robustness of the neural network created there. So first is the number of hidden layers. Adding more hidden layers of neuron generally improves accuracy to certain limit. Okay, this is very important. And this is my observation also when I used to teach neural network. So student used to do that. So 10, then 20, 30, then 100, 200. As we go on increasing it, it will not increase the accuracy. It will increase the speed, but may not increase the accuracy. It depends on the problem, depends upon the features, kind of features that we use over there. It's limited to a certain time, certain period. If it is going above that, then it may create some problems. It may have obviously slow down the system, but above certain area it is not possible to have the accuracy. Remember that we can identify by practical implementation of it also. Just try to solve many problems by MLP. I'll show you one of the problem. Then further it's possible to do. You can easily do any kind of operation with MLP. It's not that much difficult or critical. But depending upon the problem, the accuracy will be different. So it's not like if I increase hidden layers always, and accuracy will be increasing. Remember, the size of your brain, talking about, is almost same of your friends also, but still your accuracy are not same, because many reasons are there. Okay, so let's go to the second one, dropout. What percentage of neurons should be randomly killed during each epoch of to prevent overfitting? See, epoch means one step of forward pass and backward pass, that is called as the epoch. Okay, what is the percentage of neurons should be randomly killed during each epoch to prevent the overfitting. Might have learned about overfitting, underfitting, or neutral, like that. Overfitting is perfect model created, like it is using all the values perfectly on that model. That is called as overfitting. Underfitting means completely different. Data is different and model is working different, like it is underfitting. And in general, model is created and data is just revolving around that things, a common disparate accuracy that we can achieve from that. So dropout rate can also be given, that how, what is the what dropout in percentage are 0 to 1 actually. So in that we have to specify 0.6% with 60% like dropout rate, 7% like in that dropout rate can also be given there. Third is neural network activation function, which function should be used to process the input flowing into each neuron. The activation function can impact the network ability to converge and learn from different ranges of input values and also the training speed. Okay, every algorithm is sorry, every stepping step function, or sorry, every activation function is having different criteria there. Some function are straightforward, pass it, step function, pass the value directly without performing any operation there. Some function find some criteria like only pass positive values. Some function pass positive to negative and positive to positive, like that. So it takes some time. Remember, finding the maximum value, passing the values, or performing some multiplication operation, performing some division operation, different steps are taken, algorithms are used there. So obviously these things will have an impact in the output. Okay, so every activation function contains some formulas. That formulas may be complex, maybe they require some constant, maybe they require some multiplication, division, power operation involved in that. So they may take some time to perform this operation there. And it is not a part of single neuron, in single perceptron actually. Billions of perceptrons are there. If they are wasting such time, so obviously it will have an impact on training speed also. Even networks ability to converge, that's also very important. It's having that ability to perform the operations or not, and learn from different ranges of input values, and also the training speed will be speed also will be affected with the help of the respective activation function. So this will be important to identify which activation function to use over there. The last one is weight initialization. Okay, necessary to set initial weights of the first forward pass. Initial weights. Two basic options are to set the weights to zero or to the randomize them. Generally, generally, okay, we can specify these weights. Then most of the time, the random values are taken there randomly. So initially, most of the algorithms which are implemented in machine learning, deep learning, they're taken initial values in the random format. Random, just take the random values there, and after that start adjusting it. Okay, after that start adjusting it. So we adjust that random values as per our criteria, just like using backward pass, back propagation, and further using that value in the next level. Okay, however, this can result in vanishing or exploding gradient. You might have seen this concept maybe in many deep learning neural networks possible. Vanishing gradient, it's a problem for RNN also. Vanishing gradient, it can also result, which make it difficult to train the model. Okay, fine. So that may that may have a possibility like that. Training will be not done correctly, and your accuracy will drop down. So sometimes when you're making the combinations of natural language processing, when there is a data which is in unstructured format, and you convert that in structured format where a huge amount of data is created, or if you work on NLP and the deep learning combination or machine learning combination, this problem arises. Non-structured data, if you're converting structured data, it takes too much memory, and weight adjustment in such cases will be somewhat difficult. So most of the time in NLP, we don't get accuracy about 90% also. Very rarely 90% of accuracy with natural language processing is possible. Actually, Google is also working on many algorithms where they're making a combinations of neural network. Almost now they are working everything on neural network, and the technology like MLP, NLP, which is combined there, will be beneficial to have more accuracy. This case is very important to understand and use weight initialization. So to mitigate this problem, you can use a heuristic, a formula which is tied together for the number of neurons to determine the weights. That can also be used. A common heuristic approach which is used for the activation function tan H, it's called as Xavier initialization. So it's a step. Xavier initialization is a statistical method with the help of that. initial values of the weights are calculated and created by that. Xavier initialization will be used. Okay. Yeah. So hyperparameter of training algorithms. These were given to create the networks for, and now for training algorithm which is used. So for training algorithm, we can have three different hyperparameters connected with. The first parameter is neural network learning rate, case in percentages. Second is deep learning epoch, iterations, and the batch size. Okay. So these also the numerical values are there that we can specify. And third is the optimizer algorithm and the neural network momentum. Momentum is secondary. Optimizer algorithm is required. Maybe in CNN you might have seen optimizer, default optimizer is Adam that they are using, and many more optimizers are present which we can use for training algorithm. Basically, to train, we have to specify this hyperparameter, so more robust algorithm can be generated. So first, neural network learning rate. Okay. Okay, so that's what it tells how fast the back propagation algorithm perform the gradient descent. Okay, how fast it perform the gradient descent operation, and take the use of it. The lower learning rate makes the neural network train faster, but might result in missing minimum of the loss function. See, so that is what we have in the plus and minuses taken from the given learning rate over here. So with the help of the lower learning rate, so that's what we will train the algorithm faster. Learning rate, like learning rate is given in the term of percentages value from 0 to 1 there. But problem is that it may have the result in missing the minimum of the loss function. So what loss functions you applied, that loss function and the learning rate, most of the time they are connected together. So they're having impact on each other. Not exactly each other. We have impact of the learning rate on the loss function there. Okay, learning rate on the loss function. So based on that, you have your algorithm will have ability to perform operation within a specific range, and not performing the thorough operation, just like shown in the diagram over here, how the weight will change according to the loss function changes there. So neural network learning rate is also one of the important thing that hyperparameter should be present. The second one, for training algorithm, three things are mentioned here: number of epochs, then iterations, and batch size. Epoch is very commonly used terminology. If you have seen some practical implementation of the CNN and RNN, it shows that epoch 1 of 20, or 1 of 2 of 20, 3 of 20, 4 of 20, 5 of 20. Like, you can see that in output it is shown that number of epochs. In first epoch, what is the loss, what is the accuracy, what is the validation accuracy. In second, third, how it is changing, increasing, decreasing, that you can observe there. Okay, when you're actually using the Keras TensorFlow kind of networks there. So what is epoch? Epoch, iteration, and batch size. These parameters determine the rate at which the samples are fed to the model for training. Samples are fed to the model for training. So in it, epoch is a group of samples which are passed through the model together in forward pass, and then run through the back propagation backward pass to determine their optimal weights. Okay, so one phase of the forward pass and the backward pass, that is the forward pass plus the back propagation, is called as the epoch. So it's a group of samples which are passed through these two particular steps. So what should be the size of epoch? What should be the size of epoch that you have to mention also while using the training algorithm there? So most of the time when we create any kind of neural network, okay, not only talking about the MLP, but any kind of neural network, there we have to mention the number of epochs. You specify in CNN also, you might have seen, in RNN also you might have seen this particular terminology. Though when you're implementing it practically, uh, they are having the default values. Okay, you might be seen that this is a property of Python functions actually, or functions of many languages like R also. In R also same things are there. When you actually perform the operations of creating this network, every parameter contains the default values. Almost, this is my observation. Maybe if you learn in these two, R and Python, so you might have seen that these particular things are having default values also. Default values are possible, present, and based on that, optimal weights can be identified. So you just go forward, backward, forward, backward, forward, backward. Okay, with the help of epochs, and then optimal weights are calculated, and then we go to next one. So that first to second multiple times, then second to third multiple times, third to fourth multiple times. Okay, So if epoch cannot run all together due to size of the sample or complexity of network, it is split into the batches. Batches. That's also one of the hyper parameter. So what should be the size of batch? And then epoch is run in two or more iterations. So two iterations, two, three, four, five, any number of iterations can be given. So batches can also be splitted. Now, one more thing, when batch is expected, see when batch is expected, when you are having your multi-core architecture to run that, remember, multi-core. In single computer also we can do it, but it will run concurrently. It will not run parallelly. So might have seen again in the previous sessions also. Like when when I require to work on the graphics card, why I require that graphics card to work in deep learning? Because of this, I can run this system parallelly in the form of the batches. Okay, so first batch and first core, second batch and second core, third in third core, fourth in fourth core. So obviously, whatever task we are doing in 10 seconds, that can be completed within 1 second also, because that number of cores are used and we are doing the operation parallel. That's it. Okay. So epoch isn't run into or more iteration. That's also possible. Okay. Now let's have an effect of the number of epochs and the batches. Batch size per epoch can significantly affect the model's fit. See, see this is overfitting, the first case, overfitting. And what the error that is carried. So this is your sample data actually. Check it out. That's shown in the magenta color. Okay. So sample data. This is yes. So the same data is present there. Okay. So in case of epoch, so epoch may also have effect on this perfect fitting, overfitting. So just check it out. Everyone is coming under the line. So everyone is fitting inside the model, and the perfect output or perfect model generated from that. Okay. Or in case of underfitting, completely different. You are having huge amount of error there. Like your output is this, your model is this, and your data is in this direction. So you directly more than sorry, less than 50% accuracy you achieved from that. And if you are perfect and more good model, optimum kind of model generated, that can have like that. Okay. So this is how the overfitting, optimum, and underfitting things. What we require? We require optimum model. Even not overfitting also, not underfitting also. Overfitting is the problem that may arise when you are testing the data. Basically, may have completely different output. Your fitting is perfectly done, and training is done showing correct results. And testing is giving very less accuracy in that case. That may also have a problem present there, overfitting. And case of underfitting, so completely something different. Nothing is learned from that. Learned, but it is not up to the mark. That may also possible. Third case, optimizer algorithm. Optimizer algorithm and the neural network momentum. Okay, when a neural network trains, it uses an algorithm to determine the optimal weight for the model. That's called an optimizer. Okay, if you have seen the convolution neural network, there also one parameter you pass called as optimizer. The basic option is stochastic gradient descent, okay, which is used here for optimizer, but there are some other options are also present that we can make use of it. Just like the algorithm called as the ADA delta or ADAM optimizers are present. Their classes are already available in many APIs that we use to create the deep learning architecture, that directly you can apply over there. Okay. Another common algorithm called as momentum, which works by waiting after the weight is updated and updating it a second time using the delta amount. So one more parameter is this delta, which also we can pass as a hyper parameter, but it takes that value according to the optimizer algorithm you have assigned there. Optimizer algorithm contains internally its own system, and what you call own architecture there, one statistical architecture. Based on that only, the optimization of the weight is done. Okay, optimal weights can be calculated. Remember, that's what we call an optimizer algorithm there. So this speeds up training gradually with a reduced risk of oscillation. Other algorithms like Nestero accelerated gradient algorithm is there, or ADA delta is there, ADAM is there. So any one of that can be chosen. We just see if you're worked with some CNN or RNN kind of thing. So whatever models are formed, and that models are actually the classes. Just see the help of these particular classes. I'll show that in upcoming sessions also. Help of that classes. They will show all possibilities of it. Means what possible algorithms are possible, what is the possibility of batch size, what are the possibilities of the optimal algorithms, what is the possibility of loss functions, what are the possibilities of the activation functions. So based on that hyperparameter, your neural network will be formed. Okay. Now, to tune the hyperparameters, means out of all which one will be perfect for your data, there are some methods used to have fine tuning of the parameter passed to the neural network to build a robust neural network, not exactly robust but suitable for the data that we use for your algorithm there. So for common use are there, many are actually present. You just search on the IEEE's explore, so many optimization technique you can find. Just they are modifying it and new technique is created and generated. But a standard technique that we generally follow in the optimization, sorry, tuning of hyperparameters in the neural network, your multi-layer perceptron are four. First is I can we make is a manual hyperparameter tuning. So most of the time we use this method. We just don't go in detail, but it may be required to have the robust models. We use other methods also. Manual hyperparameter tuning. This method is done manually. So you decide. It's a part of practice actually. You just can think of it. Okay, where you can have achieve highest accuracy, and for this kind of the data, how much amount of what kind of hyperparameters are required. We also can decide based on our knowledge. Second is the grid search. Okay, grid search algorithm, or you can use grid search, random search also. Then you can make use of Bayesian optimization techniques also. See, manual. Traditionally, hyperparameters were tuned manually by trial and error. This is actually when someone start learning for first time with deep learning or machine learning, use this method. Why? This will give you experience. Experience. If I do this, what will happen? Okay, trial and error. How do we learn? We learn from experience. Fine. If you're not getting experience, you will not get an idea how the model is actually built. So that trial and error method will be the first one which will apply there. This is still commonly done, and experienced operators can guess the parameter value that will achieve very high accuracy in for deep learning model. Guessing what is the possibility present, or we can have trial and error like using for loop also. Some of the developer identifies what are the possible values, means good value for this particular parameter present. Just like in support vector machine, there are four kernels are present. Okay, SVM machine learning algorithm, we are having linear kernel, we are having sigmoid kernel, we are having polynomial kernel, we are having radial basis function kernel. So four parameters, which parameter is perfect, we can guess. Okay, those who are practiced with SVM, they can guess which for this data which is the proper one, or we can perform the trial and error method to identify that. So here also same things are possible. So high accuracy are possible by guessing also. However, there is a constant search for better, faster, and more automatic methods to optimize the parameters. So many are there, which are technical names I mentioned there. These algorithms can help you to identify the most good, accurate, and useful parameters for your algorithm. Okay, what are the advantages? So advantage is very simple and effective for skilled operators. Skilled operators actually. So those who are completely skilled, and those who are very new. So both of them actually use this particular method, manual tuning. Okay, simple, because you know which parameters are available. So trial and error is the common method every engineer makes use of. So we can also make use of it. Cons, not scientific. There is no any specific scientific way to know how why this technique you apply. So unknown. If you have fully optimized parameters are there, so specific scientific is not there. Scientifically it can't be proved. It can be proved, but there is no any specific reason why to choose that one. This is my favorite parameter, that's why I chosen. So every time for SVM I use RBF kernel. Why? Because my favorite kernel is there. Like, it's not like that. It's non-scientific, that's why it's a disadvantage of using it. Okay. The second is grid search. So grid search is again, this is also a very commonly scientific method. We also have used multiple number of times. Grid search is slightly more sophisticated than manual testing. It involves systematically testing multiple values of each hyperparameter. Okay, multiple values of each hyperparameter by automatically retraining the model for each value of the parameter. That grid search will do. I just have to give a set of values, possibilities are present there, and out of all possibilities, which are the which combination is the perfect for this data that will be given by the grid search. For example, you can perform a grid search for optimal batch size by automatically training the model for batch sizes between 10 to 20 sample, like 10 to 100. Let's step up 20 means first of all start from 20, 40, 60, 80, and 100. Step up 20 is present over there. Or this is first is completed, second will be 10, 30, 50, 70, 90. Okay, a gap of 2020 is given there, and we can identify which is the ideal batch size presented there. The model will run 5 times, so as I shown from 20, 40 like that, and batch size selected will be the one which yields the highest accuracy, which is yielding the highest accuracy, that will be given to you. It's a grid search. Grid search is okay, I'll show diagrammatically, get an idea between grid search and random search. What are the advantages? Maps out the problem space and provides more opportunity for the optimization. Scientific method, remember, that's why mapping the problem space is easily done. Even optimization is perfect good from grid search point of view. If you think about the machine learning, there is an algorithm called as grid search CV, cross validation. It's present in cross validation package, so there we can make use of it. In machine learning also, very commonly used technique which we use for the hyperparameter training. Okay, a disadvantage is it can be slow to run for large number of hyperparameter values. See, I given range like hundreds of parameter in single, hundreds of possible values in single parameter. So will run slow in that case. Now, the third technique is random search, which is used for training hyperparameters. According to 2012 research study by James Baxter and the Yoshia Bengio, okay, testing randomized values of hyperparameters is actually more effective than the manual search or grid search. You just can find this research paper as present in IEEE uh, by the same name. They have created this random search algorithm, and randomly, if you are choosing some element and giving the results, they are more accurate than the grid search. The grid search is doing the step of 20, random search will take in 5 steps only. So your 75% time is saved. That was proved in that particular paper, that random search algorithm that they mentioned. Okay, in other words, instead of testing systematically to cover promising areas of the problem space, it is preferable to test random values from drawn from the entire problem space, randomly take the values from the problem space and then perform the operations. But that randomization is also systematic. It's not like every is taken, so you just have to mention some points. Might have seen the algorithm of generation of random values, so they require some seed points like they are mentioned, and the ranges that's also required to mention over there. Okay, so random search also plays very important role. Even in one of the project I just have undergone through, they in that also grid search was not much effective. It was taking too much time to identify the hyperparameters for neural network, and random search is giving within 1 minute hyperparameters. Okay, so that's also one of the way by which we can identify the perfect parameters to train your neural network, MLP. What are the advantages? So according to the study, provide the higher accuracy with the less training cycle. So they are mentioned there in conclusion also, for problems with high dimensionality. When higher dimensions are there, that case its effectiveness is great, accuracy is also good. Cons: results are unintuitive, difficult to understand why hyperparameter values are chosen. That is very what are disadvantages by random search is there. Random search is still available in scikit-learn, also in Python. If you want to work for basic machine learning problem, that can also be solved with the help of the random search algorithms of hyperparameter training. Okay, see this. So they perform the operations of it. X. So first set of hyperparameters are given A, B, C. Okay, and second set of hyperparameters are given X, Y, Z. Okay, okay, and then they will make a combinations of what in the grid format. In the grid format. So first of all, the A will be taken here, then X, Y, then A, then these values of B. Okay, from B, then C, then again this one, this one, this one, then again this one, and same thing happen for this also, like in grid kind of format. Hyperparameter 1 and hyperparameter 2, they are taken. So which one to take? AX, AY, or AZ or BX, BY, BZ or CX, CY, CZ. That way. So that's a grid created, and accordingly, where the values are matching, so that value will be taken one by one, one by one, one by one. So nine possibilities are present over here. Just to that, inverse of it, we are having a random search here. Okay, random search, obviously the name suggests the meaning of it. Okay, how the operations will be done. So random search, the code is given random.num. Random is a package actually in Python, numpy. So we can create a range of element, any. It's not like ABC only, x y z are there. So any range, like you just can create it, and randomly they are plotted, and we'll take this value first, this, then this is like. Here 9 are given, here also 9 are present. Okay, sorry, here 8 are present. We can specify 6, we can specify 5, we can specify 4. Not, it's not always like according to the parameter are given. You just specify what's the range you want. Okay, in that way random search will take it. So they are not having a specific criteria to choose. Randomly values are chosen, and with the help of their combinations, we are making use of it. Okay, fine. So this is how grid search and the random search algorithms are performing the hyperparameter selection and giving the tuned output to us. So last one is Bayesian optimization. Okay, it was also one of the technique described in the Shahayari, which tries to approximate the trained model with different possible hyperparameter values. Obviously, everyone does the same, but in this technique, they are using some different method. Like, to simplify, Bayesian optimization trains the model with different hyperparameter values and observe the function generated for the model by each set of parameter values. Might be doing different Bayesian kind of different distribution of data, distributed kind of data will be used in Bayesian optimization there, and using the distribution labels, this hyperparameter tuning is done. Okay, so for each set of parameter values, these hyperparameters are observed against. Okay, where you are having higher accuracy, highest accuracy, like that. Okay, it does this over and over again, each time, selecting hyperparameter values that are slightly different and can help to plot next relevant segment of the problem space. It is actually mathematically, if you are thinking about it, somewhat complex. Even I have not used this technique in any of the algorithms ever. Complexity is more, and try to find which parameter you have to assign where. That creates very difficult situation in most of the time in Bayesian optimization technique. Okay, so similar to swapping sampling methods in statistics, the algorithm ends up with the list of possible hyperparameter value sets and model functions from which it predicts the optimal function across the entire problem set. So what are the advantages? The original study and practical experience from industry shows that Bayesian optimization results significantly higher accuracy compared to random search. Okay, I have not used, but it was shown in the paper also that they are given. And one more paper I just seen in one of the Springer journal, they are also given that higher accuracy is there for Bayesian optimization than the previous one. So this is what the sequence that we are having. Manual can have any, so from lower to higher also. Then we have some good accuracy in grid search. Then more than that, we have random search. More than that, we have hyperparameter optimization. And finally, the hyperparameter we done so much perfectly there. Okay, so disadvantages like random search results are not intuitive and difficult to improve on even by the trained operators also. Okay, now let's go with the real world. When you actually make use of this technique of the neural network, multi-layer perceptron in real world, what the practical options we are available with? Perform the manual optimization. So most of the time, whatever the developers, or most of the time, general researchers are done, they are performing the manual optimization, even leveraging hyperparameter optimization techniques in deep learning framework of your choice. Or framework will report on hyperparameter values discovered, their accuracy and the validation score. So as you go epoch by epoch, out of 100 epochs, one by one, you just can observe that how accuracy levels are changing as you change your hyperparameters, and as well as how the validation scores are also changing. Most of the time it may be possible that hyperparameters are affecting validation accuracy also. Okay, validation accuracy also epoch by epoch, means always not it is increasing or it is decreasing. not always increasing, but maybe some levels of epoch that value will be constant because of this particular problem here. Using third party hyperparameter optimization tools, they are also present. I've not used that, but still some hyperparameter optimization third party tools are also present. With the help of that, the tuning and optimization of hyperparameter is possible. So in when actually you're working on a deep learning project, on a project where the multi-layer perceptrons are being used, in that case you have to decide, so what technology, what techniques or optimization algorithms you need to apply over here so that we can get more better, perfect and acceptable result. That is the most important thing here. The fourth one after hyperparameter, the fourth is the advanced structures. Okay, complex structure that we use from the that we derive from the multi-layer perceptrons. Okay, multi-layer perceptrons. You come across these techniques already. I'll just have revision of it. For example, okay, so many neural network that use a complex structure that builds on the multi-layer perceptron. For example, the RNN, the recurrent neural network, which uses two neural networks in parallel. One runs its training data from beginning to end, in other runs from end to the beginning, which helps in language processing. Okay, means what we do, we do the predictions like connectivities are there. So there is a data which is connected together. That connectivity identification is done by RNN, and multiple neural networks, actually two are written here. One is moving forward, one is looking backward. So whatever result generated from the first network is given to the input to second network, and then just vice versa operations are done. That's what they call a recurrent neural network. They're connected together. You might have seen that one. Generally, we use in language processing. And other advanced structure, which is created from MLP, is the convolutional neural network. That is what we call a CNN, which uses a three-dimensional NLP. Yeah, might have seen that three-dimensional NLP there. And generally, we use convolutional network for image processing applications. Many times, when RGB values are there, we use convolutional network. Very commonly used technique which we use from MLP. Essentially, three-layer, multi-layer perceptron structure that learns the same data points. So actually, multiple layers of convolution are added in the CNN, convolutional network. So apart from MLP, it contains that extra things present here. As we have seen in RNN, its connectivities are present. Okay, forward to backward, backward to forward. Means output to input connectivity is also present there. In CNN, we are adding multiple layers. Okay, so every layer is having their own importance. Why you add convolution layer number one? Why you add layer number two? Layer number three? Whatever. Okay, so this is useful for color images. Okay, as I told, with the three layers of depth are present there, like red, one for green, another for blue, and then solve the problems. Like that. So this is what advanced structures which are derived with the help of the multi-layer perceptron. So that perceptron will go beyond it. It's not limited with this. So these are the two commonly used architecture. But as I told, there is architecture called as RCNN. RCNN, fast RCNN is also. FCNN is also there, which are now very novel system present in the neural network architecture. But everyone is just based on the multi-layer perceptrons. Okay, so these are the advanced structures present. And if you consider how do we implement a neural network in the real world, in the real world, perceptron work under the hood. You will run neural network using the deep learning framework like TensorFlow, Keras, PyTorch. In upcoming sessions, some of the session, I'll show how to do this operation with TensorFlow and Keras, which are very commonly used framework that we make use of them to create the networks. Almost every neural network is making a backend of Keras and TensorFlow. This framework asks you for hyperparameters such as number of layers, activation function, or type of neural network what you want to build. So actually we have to build our as per our idea. So though the class is same, your idea of building the network is different. The CNN, the layers you decide. In RNN also, connectivities of you decide like that. Okay, so neural network, type of neural network, the number of layers you decide. Even MLP also we decided. I'll show that practically how MLP decide the number of layers. How MLP, not how MLP, we decide what layers should be present over there. Then activation function, what should be present over there. So last part of today's session is activation functions, which we actually make use of in the multi-layer perceptron and construct a network of perceptrons automatically. When you work on real production scale deep learning project, you will find that the operations sides of things can be bit daunting. So as I told in the previous slide also, uh, the time is very important factor that to know, time and data, because most of the data is very huge, very high, huge amount of data is present. So the data is in GBs, and you have to process, and then you have to build the model based on that. And not only the static model created, static means I have created, now it is built, not like that. You have to build a dynamic model. Dynamic means if data is coming, it should get trained along with the same model and then perform the operation with that. So how this model is saved, how it is loaded, how it is modified, like that things are present in the real world situation of neural network when they are created. So to build a network, as I told, previously created hardware, software, both are present. They should be present to create a production scale deep learning project. That things you need to remember. And actually when industries are working on that, they're making use of the libraries, they're making use of different frameworks, like which I mentioned over here. And common language is just like Python. Even in R also, it's possible to create the neural network, but as the experience of performances, plus one more thing, that inter-technology connectivity, Python is very commonly chosen, and these frameworks are available in Python, so you can make use of the neural network so much easily with the help of multi-layer perceptrons here. Okay, running experiments at scale and tracking results, source code, metrics, and hyperparameters, all of this, with that required to be considered here. To succeed at deep learning, you need to run large number of experiments and manage them correctly to see what worked. See, hyperparameter tuning, first parameter is trial and error methods. Like many time, though it's think that every time you have to work on scientific, but actually when the done deployment is done, many times you have to work on trial and error method. Okay, which I mentioned here, results tracking. Okay, maybe some codes are very robust or they are not having bugs, but when you apply to your project, that they become buggy and not supporting to it. So debugging such kind of the codes and making use of another part of code instead of that, that's also very critical part present here. Even hyperparameter also, which is required here. I was working in one of the project in the automobiles, where we are giving almost 41 entries, 41 features are given. Then out of 41 features, you have to work on the algorithm to perform the prediction. It was actually a regression kind of algorithm, not classification. But out of 41 features, which features are important to understand, it has taken almost 3 weeks to finalize. Hyperparameters are very, very important to tune, and then you're applying that in the MLPs in that case. Okay, running experiments across the multiple machines. Okay, multiple machines, as can see, distributed architecture can also be used. Even in machine learning also, commonly distributed architecture can also be used to run your system across multiple machines. In most cases, neural network are computationally intensive. To work efficiently, you will need to run experiments on multiple machines. This require provisioning this machine and distributing the work. So as it's a platform independence actually, but is it working on all kind of machine? It's how much performance it is giving there. If it is working perfectly with the help of this GUI, like for example, I want to create a desktop application of that product, I can use a Tkinter package, or I can use the Kiwi, or I can use the Qt also. With the help of that, the GUI is possible. So what's the performance on GUI for this model? And I can make use of a Django or Flask also to deploy that application in the web framework, web application. Like, so what's the performance over there? Or if I created the model, build the model, but my GUI is created using Java. Okay, by using Java desktop application or web application, what's the performance over there? So every time performance will be different. So basically, the task of your your neural network in real world is to improve the accuracy, make perfect prediction with minimum amount of the time. Okay, so whatever is suitable, it's not like the requirements are there. Requirements are there, obviously requirements will be there from the client's end, but but second thing is that which particular platform is giving you the highest performance, that's also required to know. See what the project that Even I have done in multiple different for different companies with deployment. We are suggested to do on Linux only machine. So because performance was good in that particular case, that's why it's required. Though we think that everything is platform independent, but performance independence is not there. So performance is different for different kind of machines. If you're accessing the things in a mobile with 4 GB RAM and accessing thing your laptop with 4 GB RAM, performance are different. Remember, because many factors are there which are affecting over there. So experiments are executed across multiple machine. Even some projects also we need to work on IoT based application systems. So IoT based application systems are used with the hardware, like we are using some microcontrollers or some microprocessors are there. They are collecting the data. They are lightweight microprocessors. And if you are using the deep learning on that lightweight microprocessor, it will hang the system directly. Solution is that when you have to actually deploy, it's required to deploy on the clouds also many number of times. Once deployed on the cloud, it will be the care of execution and controlling will be taken by the cloud itself through the network. So local system will not be responsible for the performance will not be affected much, because the performance or the what they are cloud is providing everything to us. So based on that, we can have a support. We can make use of effective implementation of it in real world. Remember, every project is deployed separately as per performance requirement, robustness, and many different parameters are present. So in real world, MLP are used. So that point, that things are required to get considered very regularly in systems. Okay. And managing the training data. So where to store it, where can I use it? The more training data you provide, the better model will learn and perform. Obviously, this is a rule in machine learning, deep learning, everywhere, artificial intelligence also. So data is forming a core base for these technologies here. More training data, better model, better performance. So there are files to manage and copy the training machines. If your model's input is multimedia, those files can weigh anywhere from gigabytes to the petabytes. See, some projects which are using the MLPs. So data is stored at one location, algorithm is running from another location, and the user interface is another location. Three places are there that actually we use. Why? Because a rise of new technology called as big data. Might have heard about big data. When data is in huge amount, so we have to change your techniques, change your technology. Your data is in high stream amount. It is coming from 10 Mbps continuously, and you have to do the prediction in that particular speed. So what to do? So that points also required to consider how to manage the training data, how we store it, how you copy it, and how you actually apply the real world situation on machine your perceptron classifiers onto it and generate the results so much effectively possibly out of it. So in real world, these things are considered. Basically, if you're thinking from MLP point of view, accuracy is not that much the biggest concern there. But in case of common basic machine learning algorithm, this is playing very important role to maintain the accuracy in such cases. Now come with the last point of the theory part. I'll show a simple practical application of it also. Not practical means in general real world situations. Activation functions. Okay, what is activation function? So in the whole diagram of your MLP, we have seen the activation function, which is just like a step function by which we perform the operation of extracting the important features out of it. So the activation function, they are the crucial component of the deep learning. Activation functions determine the output of deep learning model, its accuracy, and also the computational efficiency of training model, which can make or break the large scale neural network. See, this is make or break. That can be done. That's power activation function is having. So activation function is the neuron. It's an actual neuron, or what we call a nucleus of neuron. Nucleus, where it's the center of it. Just like we have a brain, brain is having a neuron. Nucleus. Neuron is having a nucleus. So nucleus is the activation function there. So it can also, it's having ability to make or break the large scale neural network. So that you think that you are having a huge amount, a huge network created and will do high performance to you. But if your activation function is not having capability to handle that data, so fail. Remember. So activation function also have a major effect on the neural network's ability to converge and the convergence speed or in some cases, activation function might prevent neural network from converging in first place. Okay, so they are the mathematical equations that determine the output of the neural network. Mathematical equations are there, so which maybe a mathematical equation that you are already knowing. They are commonly used over here. The function is attached to each neuron in the network and determines whether it should be activated, fired, activated or fired or not, based on whether each neuron's input is relevant for the model's prediction. Activation functions also help normalize the output of each neuron to the range between 1 and 0 or between -1 and 1. We have already seen this in the previous topics also. Normalizing of the output is done by these particular things. Activation function will help us to perform these operations here. So, in additional aspect of activation function is that they must be computationally efficient. It should be done, but not much complexity should be present there, because they are calculated across the thousands of even millions of neurons for each data sample. For each data sample, activation function is used. Okay. The modern neural network uses a technique called as backpropagation that we have seen to train the model, which places an increased computational strain on the activation function and its derivative function there. That's why activation functions obviously plays important role in 2 points. First, accuracy, and second, performance. Accuracy and performance. It's not like you are increasing a layer and you increase the accuracy. But if you change the activation function, there's a possibility that you can have good accuracy, because it will be applicable to the data so much effectively. So that's why we are getting highest amount of accuracy out of it. So that is important to know about the activation function when it's used, and which one to use, and what's the application is. Means what exactly activation function does, what task is involved in that. Okay. Now see, common activation functions. I just given two here, sigmoid and tanh. Their comparison is shown how they actually perform the operation. Might have learned about sigmoid in logistic regression. I'll show that one also. So there are multiple kind of networks are present, and how activation functions are connected, that also will see. Artificial neural network. The first, the two terminologies are used here, ANN and the DNN. Artificial neural network are comprised of large number of simple elements called neurons, and each of which makes simple decisions. Together, the neurons can provide accurate answers to some complex problems, such as NLP, natural language processing. Okay, maybe you have seen some case study. Maybe you have seen some case study in computer vision, that is computer image processing, and artificial intelligence. A neural network can shallow, meaning it has an input layer of neuron and only one hidden layer is there. It processes the input and output layer that provide the final output in the model. Connected to that, we are having another network that's called a deep neural network, which is having commonly two and more additional layers of neuron, like this. So hidden layers are having activation functions here. So non-deep feed forward neural network. Check this. And deep neural network. So n number of hidden layers are there. Okay, you can just check it out. N number of hidden layers are there. We decide how many hidden layers you want. Okay, in practical, I'll show you how can I assign the hidden layers here, and based on that, the outputs will be generated from there. Okay. Now, what's the role of activation function which is played in it? So numeric data points, which we call as inputs, are fed to neurons in input layer, and each neuron has weight, as we see, multiplying the input with the weight gives a neuron, is transferred to the next layer. Fine. After that, activation function is a mathematical gate in between the input feeding the current neuron and its output going to the next layer. Mathematical gate. It can be as simple as a step function that turns the neuron on or off, 0 or 1, whether to proceed or not to proceed. Okay, depending upon a rule or a threshold value decide. Or it can be a transformation that map the input signal into output signals that are needed for the neural network's function to perform the operations with. That's called a step function. See, here we have an input and activation function. So this is shown over here, it's just like a sigmoid function which is used, and based on that we generate the output. Okay, a common neuron is having this kind of functionality. Now, processes carried out by the neuron. So, how exactly activation function performs it? So, it takes the input, multiply the neuron's weight, then adds the bias. These things we have seen. First step over, second step is over. The next in MLP, feed the result x to the activation function f of x. So, whatever result is generated here by adding the bias, multiplying the weights, then adding the bias, we got the activation function, which is passed over here. And based on that, the outputs are generated and transmitted to the next layer of neurons, like that will be transmitted. So, and we got the output generated for the next layer of, and then again next layer, the activation function is present. Will take adjust the weights, take the data, perform the operation, gain the experience, and transfer to the next layer, like that. So this is how the process are carried out with the help of a single neuron, which is containing activation function to perform operations on. Now, there are three kind of activation functions are present in it. The first function is binary step function. Second is okay. First means there is a group of functions actually. Second are linear activation function, and third are the non-linear activation functions. So they, by their category name, you can identify what sort of functions are present in that. Binary means two possibilities are there: linear, the generating the linear results; non-linear, obviously non-linears. See, binary step function. Okay, binary step function is a threshold-based activation function. If the input value is above or below certain value threshold, then the neuron is activated. Okay, neuron is activated and send the exactly same signal to the next layer. This is called as a step function. The problem with step function is that it does not allow multi-valued output, that it cannot support classifying input into several categories. You can check it out. As see, for example, I want to identify whether temperature is low or high. Temperature is low or high. So will result that value like 35 degrees. So 35 degrees is a continuous value, but output we require in high or low. So 35 degrees high, 28-degree low. Why? Because 30 is the threshold there. So 30 is the threshold. If I'm getting the value above that, will forward 1, and if it is below that, forward 0. This way. This is what is a binary step function, which is commonly used in generalized multi-layer perceptron. Now, the other functions like linear activation functions. So in case of linear function, they take the input multiplied with the weights for each neuron and creates the output signal proportional to the input. Proportional. So you are knowing linear regression contains proportionality of linearity there. So in one sense, a linear function is better than a step function because it allows multiple outputs, not just yes and no. Yes, multiple outputs are allowed. Yes and no is present in binary step function, but here we have the things like yes and no, beyond yes and no, like binary and multi-class classifications are possible with the help of linear activation functions presented here. Okay, what are the problems with that? It's not possible to use the back propagation in that case to train the model, and all the layers of the neural network collapse into one. Okay, there are the two problems present with linear activation functions. Next, we have the non-linear activation functions. Modern neural network models use a non-linear activation. Currently, we have many functions added in the neural network. Out of it, many are non-linear. They allow model to create complex mapping between the network's input and outputs, which are essential for learning and modeling complex data such as images, videos, audios, datasets which are non-linear and high dimension. So to solve this kind of the problem, non-linear activation functions are basically used, right? Remember that. So when you use this kind of the data, non-linear functions are preferred. Almost any process imaginable can be represented as a functional computation in a neural network, provided that activation function is non-linear. Problem is they addresses the problem of the linear activation function, basically allow back propagation because they have derivation function. Many things are there. See, there are the common non-linear functions present with us, which are used for firing the neuron. Okay, let's take an overview of it. So time is almost coming over. So let's take an overview of all of these function, non-linear functions present in this. Sigmoid or logistic. See, this function is used in logistic regression. If you have known that this is the extension of linear regression extension, you might be knowing, and used for classification basically. So probability based kind of prediction classification is done by this. Okay, if your value predicted is below 50, probability is below 0.5 presented over here, will go to class number 0, and if it is above this, it will go to class number 1. Okay, logistic regression formula is there. This is your sigmoid or logistic function present. With the help of that, the classification will be done. Okay, like this presented here. Sigmoid or logistic function is present. So a smooth gradient preventing the jumps to output values possible. Output values bound between 0 and 1, normalizing the output of each neuron. So it's a probability based actually, which is used in logistic regression also for classification, but it's no means regression, but it's for classification system. Okay. Then next is tanh, that is hyperbolic tan. Advantages like zero centered, making it easier. Okay, why what we use tan of hyperbolic tan is tan h of the value is calculated and then forwarded there, making it easier to model input that have strongly negative, neutral, and strongly positive values. Otherwise, the sigmoid function it's like a sigmoid function there. See this one. This curve is something more clear. Okay. ReLU. Maybe if I use that function in the CNN or RNN, generally use ReLU function. So max of 0 and Z value means only positive values forward, positive or 0. ReLU does rectified linear unit. Positive or 0 means negative values will not be considered in that using the ReLU function. It is again computationally efficient, allows the network to converge very quickly, and non-linear, although it's look like a linear function. Remember, it's looking that linear function. It has a derivative function and allows for the back propagation there. Okay. Then next is leaky ReLU. So it's prevent the dying ReLU function problem, which is variation of ReLU has a small positive slope in the negative there. See, just observe that here it's completely negative, constant slope. So here don't have that one. See this one, leaky ReLU. Okay, so it does enable a back propagation even for negative values also. Okay, fine. Result are inconsistent, and this is what we have leaky ReLU. Along with that, parametric ReLU is also there. Y is equal to ax function is used for that. Parametric ReLU allows negative slope of learn, like leaky ReLU. This function provides a slope of negative part of the function as an argument. And softmax. This is the softmax function. If inputs are like that, based on this function, probabilities are identified. So see class. See, in this particular case, where the high probability is there, class number 1, 0, 1, 2, 3, and 4. 5 output possibilities are there. So where the higher probability is present, 0.90 here. So class will be 1 for this case. This is just an example shown by using the softmax activation function. Okay. So it's able to handle multiple classes only in one class, other activation function, just like that. Probability based softmax is also find the probability of the respective uh, layers. Probabilities are found where high probability, so we'll go with that. If we combine all together, we'll have 100%. And the last is swish. It's a new self-gated activation function discovered by researcher Google. Their paper is available. White paper is available on Google's website, the machine learning. According to their paper, it performed better than ReLU, which is similar to level of computational efficiency. Okay. ReLU is very commonly used in CNN. We generally use ReLU for that, but Swish is also one of the good idea to apply and there. But current libraries were not having that. Now the current version of TensorFlow, we can make use of the Swish function also, by which more accurate MLP classifiers can be created from there. Okay, so check it out all of the summaries. What are the functions that they carry out over there, and based on that, how the model is actually outperforming, that is shown over here. Okay. So what are the challenges while choosing the activation function? So while selecting and switching activation function in deep learning framework is easy, you will find that managing multiple experiments and trying different activation function on large test data sets are actually challenging. So it is difficult actually to track experiment progress, sorry, run experiment across multiple machines and manage the training data. Okay, because of many reasons we already seen about the same. Okay. Now, a last topic. Let's have a simple demo of the classic example of creating the neural network. So this is I've taken this reference from the friendly introduction to RNN from Luis Serrano. Just created that, and he has devised how neural network is actually created. Okay, so see, a person or I am is there. I'm present there. So I want to perfect roommates. I'm living alone. So on So I require a perfect roommate who will cook for me. So I'm not having cooking abilities. So a roommate is required who is cooking. So he may cook either apple pie, burger, or the chicken. So I actually perform operation this with the help of the neural network. See, the I got a roommate, perfect roommate, but that roommate actually cooks according to the environmental conditions. Like when the outside atmosphere is sunny, so he is cooking apple pie, and when atmosphere is rainy, he is cooking burger like that. My roommate. Okay, these are the situations. So he's working according to weather. This is the condition. So weather is your input, correct? So based on weather, you have to generate this particular output. So my data set carries when I'm having this is input, I'm having this as the output. When I'm this as the input, this is the output. Okay. So the roommate is cooking according to weather. So weather is the conditional variable over here. Now see how the neural network will be formed from this. So for example, this is my neural network. My input is sunny, my output is apple pie. And when my input is rainy, my output will be the burger. Now, let's consider how it is actually converted into the neural network format. Neural network, neural network will assign the vectors to them. Like, how many possibilities of inputs are there? Possibility of input are two. That is sunny and rainy. So I'll have a vector of two elements. For sunny, it is 1, 0. For rainy, it is 0, 1. Okay, and my outputs are three possibilities are present. So output will be containing three binary values present here. So for apple pie, I'll be having 100. For burger, 010. For chicken, 001. Chicken is not cooked actually, but let's see whether the neural network is giving this result or not. Continue. Now when you put that value into the neural network, so like in this way, my input is 01, output will be 010. And when output is 10, input is 10, output will be 100. Okay, that is your apple pie, and now it is burger present here. Now conceptualize it. Now here your weight adjustment is done. See this one. This is your input 1001. This is your output, which is having three elements present over here. Three, maybe 000111, or combinations of them. And this is your weight adjusted finally in the neural network. This is the matrix which is multiplied to this particular matrix or the vector. Okay, when you multiply it, you just observe it now. So if I multiply this input, okay, this input by the particular matrix, okay, I'll get this output. That is, it means that when my input is rainy, I'm getting a burger as the output, this matrix as output 010. And when I multiply this with this particular weighted matrix, so I'll get this output 100. You just can try that. I'll share presentations with you. So when I multiply this with this, I'll get burger, sorry, apple pie. And when I multiply this with this, I'll get the burger, like that, in this way. So when input is this, output will be this, input is this, output will be this. This is your weights. These are the weights. And how these weights are put, let's see. This is a neural network finally created. So my network or these adjusted weights I have converted like that. You can just observe it now. My input is this, and neural network is created here. Here 10, which I am feeding now, and based on outputs are generated. What is the matrix I have given over here? They are adjusted here. Okay, so 100. Okay, these three values 1, 0, and 0. So it's coming from first node 100 here 3, and second is 010, 010. For the second node it's connected. Okay, multiplication of it. And now let's look at this. Is network is created, one output layer, no hidden layers are there. Input layer is one, output layer is one. So three outputs are expected as three nodes, and two inputs are there. That's why two nodes present over here. So when I'm giving 10, whatever the weights are given, they will be multiplied, and I will generate the output. So if I given 10 here, so 1 into 1, 1, 1 into 0, 0, and 0 into 0. Okay, 0 into 0 is 0. So I'll got 100. Output layer is generating apple pie. And if I give this value 0, 1 here, 0 and 1 over here, it means that it is rainy. So I'll get the output here 0, 1, and 0, which is burger. Okay, so this is how the concepts are created, how exactly every number is converted into binary format, and then accordingly the classes are defined. So this is the way how actually the neural network perform the operation means multi-layer perceptron actually perform the operations there. You decide what operation you have to do. So just like in this example, uh, here we have not used the activation function directly. Activation function is required when you are using the multi-layer. These are the multi-layers are not there. This is a common simple input output I just mentioned, but how they are connected and how they are forming the final results, okay, that was shown over here. This is how the multi-layer perceptron or the network which contains more than one perceptron connectively are shown there. Okay, so in the upcoming session I'll show the practical demonstration of it, how can I solve the problem with the help of the MLP there. Till then, if you're having any questions and doubts, so you just can ask. So this is from my side. Thank you. Thanks a lot.
Participant, if you have any question,
You can put in the chat box also.
if you have any question, you can put in
Yeah.
chat box, or
So
otherwise you can unmute yourself and go ahead with the question.
Any questions, audience?
I think for some of the participant, yeah, I think some of the participant, you were not clearly audible, but for us you were audible clearly. I don't know, from network issue, maybe from their side.
yeah.
Yes. Sir, can we have your mail ID so we can share it with the participant? So if they have,
Yeah. I'll post in the chat box.
yes. Yes, if a participant have any question, they can directly mail to him. So he will reply to your queries if you have any real-time queries. I think there are no questions from the participants. Yeah. So with the permission of Chair, with the permission of Chair, Madam, I propose a vote of thanks. It's my privilege to propose a vote of thanks. Thank you very much, sir, for this informative session. And you cover a lot of things in this presentation, like the multi-layer perceptron and structure of perceptron. Then it's a transformation, and then backpropagation, and then hyperparameters, model versus hyperparameters, then hyperparameters of neural network, hyperparameters training algorithm, optimizer algorithm, hyperparameters tuning methods, manual tuning. All these things were very crucial, and actually were very new. In it, today is the 9th day of this session, and this is very new things that a participant learn. That was very, so I hope it was very informative session for the participants too. So I hope all participants, I hope all participants learn and enjoyed this lot. So yeah, Chaya madam, over to you.
Yes, sir. Section was very informative, and Sir, session was very informative, and you covered all the mathematical concept behind this topic. So this is the some of the participants have asked that portion also. So that portion you have covered very nicely. And again, we are meeting in this coming days. Yes, sir. Am I audible, Tushar, sir?
Yeah, yeah, ma'am.
Yes, sir. So it is
Thank you.
very nice uh, information and mathematical concept. Basically, we covered all these things. So thank you very much, sir. And again, participants are asking for the presentation also. If it is feasible, please you mail that thing so that
Yeah, yeah,
we distribute to this
yeah, yeah. I
participant.
will send to you,
Yes,
so you just can distribute to all.
yes, sir.
Okay. Yeah,
Thanks a lot, sir. Thank you, sir. Again, we are
yeah,
meeting in the coming days.
yeah. Thank you, ma'am.
Okay, sir. Thank you, sir. So tomorrow's session again will be start at 10 o'clock only by Mahesh Khartare, sir. So all the participants, please make a note that again it will start around 10 o'clock only. Sir, thank you very much, sir. Tushar, sir. Thank you, sir.